think it would be interesting to talk about some of the waste data you've put together, Charles. And so,
okay. So did you download? Yeah, okay. Yeah, this is the latest one. I think I just updated it yesterday.
Yes, exactly. So I was tinkering on this throughout the past week, and yes, I saw you just made a commit. It looks like yesterday at some point. So I've been looking over it, but I may not have all of your latest work. So, if you want to share any of that while we go through it, then yeah, that would be awesome.
Okay.
So essentially, just to give you some background here, Sela, you can do freedom of information requests from here in Washington, from the Liquor and Cannabis Board, and you'll get a data dump that looks like this, where if you're requesting traceability data, so they'll return essentially zipped folders of the different endpoints. So these are the various endpoints of the traceability API. So for example, licensees record their sales, they record how many plants they have, they record their lab results, their inventory, and tucked away down here in batches, we've found that they actually record how much waste they generate. And there's a company, Better Carbon Solutions, and they're, as far as I know, the only, well, actually, there's maybe a second one up in Bellevue or Bellingham, but these are the ones that I personally know that are working on a solution for hemp and cannabis waste, and they have no idea how much waste there is. So we're going to try to make some estimates. Really just for fun, but so we'll need this data. Let me actually pause for 1 second while I load in the data here. So 1 second here. I forgot to get the data. One second. Okay. So downloaded some data sets here. The batches, although it looks like it's about 1 gigabyte of data in the zipped folder, and when you unzip it, you'll see that the data file here of batches is 20 gigabytes. So that's a large amount of data. And my laptop has 16 gigabytes of RAM, so cannot read in this entire data file in one go. So there's a couple tools we can use to approach this. So Charles showed me Dask, which is, it implements the pandas data frame. So it's similar to working with pandas. And so you can think about it as, instead of just reading in, everything all at once, you're sort of chunking this. It may be that Dask hasn't implemented everything, but I actually didn't have the greatest luck reading in this data with Dask. Did you run into similar issues, Charles?
Yes. So I had to read it in with pandas, save it as a Parquet file, and then Dask would read it in. But I was lucky enough that my Mac has an infinite swap file. It'll just keep expanding it until apparently it uses up the entire disk. Where on Windows, right? You're using Windows, right?
Yes.
So maybe your swap file isn't big enough, or Windows has some limit. I don't know. On my Linux machine, I had to change the size of the swap file in order to get it to work. But yeah, it does not like that file. It will not read it as a CSV. I don't know if I can I'm not sure how big those Parquet files are, if I can share them easily.
So it's not the end of the world, because, that's why we've got Python here, is to sort of make the unmanageable manageable. So this is the code that Charles has written here. So I've just snagged Charles's code from here, and Charles has actually done an awesome analysis here. And so, Stella, you may want to go through here, because here Charles has actually really just walked through the steps you need to as you're going about data. So, for example, you've read in the data, and you started to look at it. And I love what you did here. Almost one of the very first things you did was simply describe the data. So just to see, what are we working with here? So we're working with, what's this? 37 million plants. So that's a lot of plants. And so that's real, it's real cool data that, they're not really, recording, 37 million tomato plants out there. And so it's so cool that, we've got such granular data on the cannabis industry. So enough fawning over Charles's analysis here, because we can revisit this here in a second. So just to make this manageable here, just for the time being, just for the presentation, essentially, what you can do with pandas is you can just essentially just read in a number of rows at a time. And so the way I was going to approach this problem, since I've got a limited bandwidth here, or limited memory, and I'm having problems with Dask, it was essentially just going to chunk it. So just read in 10,000 observations at a time, or can play with that number, and essentially the data point we're after is what Charles has calculated here as the amount of waste by producer by date. And I was thinking, you know, if we group them in 10,000s, we can calculate the waste by producer by date and then save that. And then we can basically then read in all those files and then combine, you know, essentially combine that data, right? Because there won't be any data loss. We're just looking for the total, so we can, you know, break the total up, you know, so it doesn't really even necessarily matter how the data is sorted. You know, it'll be nice if the data is kind of nicely in order, but the chunks can split things up because we're, at the end of the day, we're just looking for the total. So, the long story short, just for today's demonstration, we'll just do one with a chunk of 10,000, and then what I'm going to be working with, unless Charles has a more elegant solution, but well, Charles does have a more elegant solution. I just don't have quite enough memory for it. So basically, you know, I'm just going to kind of walk through this Stack Overflow. So how can I read in a huge CSV file? Well, basically, we're just going to have to iterate over the data frame, read in chunk by chunk, calculate the waste by producer by date, save it, aggregate it, and then hopefully at that point, we'll have just a nice, you know, a nice series. In fact, we may even aggregate it further and just do total waste by date. That's, I think, an informative number. We'll, you know, revisit the producer by date as well. But long story short, let's start here with this chunk. And just for expedience sake, I just gone ahead and read it in here. So basically, I just, you know, this will just save us a tidbit of time. But basically what Charles has done here is he's defined the columns that we actually need to read in. So this is sort of a little bit of advanced work, or a little bit of a, you know, thanks to Charles's foresight, we can kind of leapfrog a little bit. So we already know like what columns are in the data. But if you were reading this in for the first time, you may not know what columns you even have. But long story short, we're going to read in 10,000. I'm skipping 2 million observations because for whatever reason, a lot of the observations at the beginning of the data, there was no waste. So just for today, I wanted to get a chunk that actually had waste. So we've got the waste data here. We can describe it as Charles did. Here we've just got 10,000 plants, and we've got the amount of, you know, well, let's actually see what, you know, columns we have here. So for example, we've got the flower dry weight, which of course is what the producers care about. But the other half of that is the waste. And so that's what Better Carbon Solutions cares about. So they're trying to get that waste off of their hands and compost it essentially through pyrolysis, and so they can make products with it instead of it going into the landfill. And so Charles noted here that we've got some negative values. And so Charles, I ran into just an error when I ran this line for some reason. So correct. So I just approached this as just essentially taking the absolute value of the waste. So let me know if that achieves the same outcome. But basically, there were negative values for waste.
Yeah, actually, that's a good solution. I didn't think about that.
Well, yours was perfectly fine, but I was just ran into an error. We'll see here. I'll show you. Well, that time it worked. For some reason, the first time I ran it, I ran into an error of some sort. So anyways, either way works. Okay. Okay. So I actually haven't really walked through this line here. So let's see here. So let's see. Okay, so here you're filling in the plant stage.
Oh yeah, there were some places where it was NA, and that will cause problems later on. So,
All right, and so basically we're assuming if there's no plant stage given, then it's harvested essentially.
Right. Oh yeah, and I filled it in with the most common value, which is that's a technique that's pretty common.
Excellent. Well, this is why it's nice to have you here while we walk through this. Find the amount of waste. Okay, so now we're just looking at waste for harvested products. Is that correct?
Yeah, because if you take all the different stages, the analysis you get is kind of murky. So if you break it up by the stages, you get a sort of a clearer picture.
And we describe just the waste. Okay, so do we know if this is, do we know what the unit of measure is by any chance?
So at this point, it should be grams. There's a point where I convert it to kilograms, but I don't think, yeah, that's not here yet. Because some of the numbers are really huge. And it just sort of made more sense to present it in kilograms.
Here we are with your analysis. So we've sort of skipped over some things, but like I said, you've done some thorough analysis here. So here are some charts Charles has presented or prepared. So this is better since you have the full data set here.
So there's a lot of data that's where all the dates are 1/1/1900, which of course doesn't make any sense, doesn't really help. There's some pre-2012 dates, and there's some pre-2018 dates. And this data is sort of supposed to be from 2018 forward. So I cleared that out, and I just kind of went from 2018 forward.
Question. I see. Did you eventually just basically abandon harvest date and just decide to go with updated at date, essentially?
Yes, because if you go up, I explain why I do that. Yeah, there's 87, almost 88% of the data has a harvest date before 2018. So it's not really, it's not a good date. And there's a lot of harvested dates that are 1/1/1900. So basically, there's not really, they don't do any data checking when they add this data to the database.
And and Sella, you may be able to speak to this, but I think my experience with the traceability system, I would go exactly with the updated at date because this is essentially going to be a automatically generated number by the traceability system. As you noted, if they, revisited their harvest at a later date, just say they made an error and then they fixed their error, then the updated at time would change. But I think that's a smaller error than whatever's going on here. Um, right? Because at the end of the day, we're trying to minimize our sort of our bias, our forecasting. So when you have entry errors like this, that actually introduces statistical bias into your calculations. So, the closer you are to the true value, the better. And so, yes, the updated at there may still be errors in the updated at times, but I think as you settled on, it's just going to be I think it's going to be a much reliable measure of time than the harvest date.
Yeah.
Yeah. But and that's why, rule number one is look at the data. So the fantastic work there, Charles, because all you really need to do is you plot those, and now we know how we can keep track of time. So I think this is a real cool chart here where this is just showing the amount of waste generated. I think essentially are these like essentially
By day.
Okay, so these are totals by day or by producer by day?
By day. We get down to by producer later on.
Interesting. So maybe some of these are when the larger producers harvest and there's a lot of waste. Ooh, cool charts here. Are these new?
Probably. I've been, sort of I'm thinking about it and updating it, and like how can I improve it? And
this is fantastic. I haven't seen this chart yet, so I think you may have added this since I was looking at it, because this is exactly what needed to be plotted. So thank you, Charles. Like, awesome work here. So this is essentially what everybody's been curious about. I don't think anybody's plotted this. In fact, I'll have to share an article with you, Charles. There's an article in The Stranger. Washington State has I forget what the title is. Like, Washington State has a 1,000,000-ton waste problem or something like that. I'll share the article with you. And so essentially the author was calling around to like recycling places, trying to figure out like what the actual weight of waste is. And he just sort of made estimates. because like this data, well, he actually wrote this article back in 2017. So before this data was there. And as we found out, the data is tough to wrangle. So although the data is there, and as you showed, we can calculate them, I don't know if anybody has. And so this, Charles, you really may be the first person who's plotted harvest weight by month. So good work. And so this is it. I'll just give you my hot take, my first look here. It's incredibly interesting to observe this large amount in 2018. And I want to say that may be producers essentially entering their essentially initial inventory into the traceability system.
Okay.
So
I wondered about that. Actually, if you go down to the next chart, I cut off February and March, and then I also cut off January of 2021 because that was incomplete. And then I thought the other two were outliers. So I think this is more representative of the actual data.
yes, I think you're right. This is and this way the scale, you have a better idea of the scale. So just to explain, I think so. Basically, the traceability system was introduced in January or February of 2018, and they had a contingency period where they had to essentially enter all, because these were companies that were already operational with the BioTrack traceability system. So there, before Leaf Data Systems, there was BioTrack. So they're already operational, and they're given a contingency period through roughly April of 2018. I'll actually want to double check I'll have to do some, because if you look at the press releases, they may have pushed back the contingency period, but around April of 2018 was sort of the deadline to get all your inventory into the system. So that's real curious. So maybe people just had like a bunch of waste sitting around and they just had to get that entered.
If you look, there's definitely a lot of pre-2018 dates in some of this data. So I think they just must have had, entered data maybe from the previous year, or but yeah, anyway, it just kind of those couple months sort of skewed things. So I just decided to drop them because after you drop them, you sort of see kind of a trend.
And this is where you get to the art of data science. So one thing we're going to be getting to here is forecasting, right? So we'll want to forecast this forward, 12 months, to kind of predict 2021. My technique of not my technique. A technique of forecasting is, ARIMA forecasting. Box Jenkins, where you just take historic data and you basically use statistics to calculate the sort of like a moving average, and you just basically continue the moving average out into the future. So it's atheoretical, and it forecasts fairly well with time series, surprisingly well. So, but one thing, if you were doing Box-Jenkins forecasting, if you included all these observations in there, you may get wonky forecasts because if you conclude these observations, the box Jenkins may like put like this negative trend on waste, but if you really exclude those prior years and you just look at the more recent data, you know, it's not really obvious there's a negative trend per se. Perhaps, but not like there was at first glance. So just to kind of, I guess, look through some more of your analysis here, I guess, before we get to forecasting. So I guess let's just look at the totals here. So this is 30,000 kilograms.
It's a lot.
It's hard to quantify. So what would be an interesting analysis is, so actually somebody at Better Carbon Solutions recommended this. So I forget the amount of weight he said, but basically to help visualize this, you may want to think about like barrels. So I forget the amount of weight, but like let's say you can like fit like 50, like say 50 pounds in a barrel or something like that. It would be, I think it would be easier to visualize if you said, oh, there were, you know, 1,000 barrels of waste in a given month, because, you know, that way, you know, people could visualize sort of what, you know, 1,000 barrels of waste would look like that would, like, you know, fill up like a warehouse. But when you just say, you know, 30,000 kilograms, it's really hard to have any idea. Like, I don't have, I mean, maybe some people who are a bit more of metric mindset may have a bit more mental framework for that, but I can't really visualize that. But anywho,
something else that just occurred to me that I don't know if it would contribute to the outliers, but at least when I was working at Northwest Cannabis Solutions, the folks who finance and kind of like own everything were these Russian dudes. And I remember that one year they lost like over half their crop because they didn't know what they were doing. And so I don't know if that would contribute at all to sort of like their waste production, but that is something that just occurred to me, is like, I remember they had really serious issues with growing, and a lot of their crop just like wouldn't make it, and they would lose entire swaths of like plants at a time, until they kind of dialed it in and got it figured out. And they're a pretty large producer as well, from what I understand. So it's possible that kind of thing can contribute, but definitely for sure 30,000 kilograms is like a wild number. Even as somebody who has like worked in cannabis and seen literally like entire dumpster sized like containers of like plant matter and stuff, it's pretty wild. But
wow, no, that's interesting. That kind of helps make sense of some of this data, because there are some like huge losses. It's hard to picture, but that does help.
That's good anecdotal story from the ground floor, because it helps. That's what I think we were talking about last week. Is it's part of data science is telling us the story of the data.
Right.
And so it's like a real good story where you kind of highlight just some of these individual days where like there were maybe like hundreds or thousands of grams of waste in a given day, and you're trying to even tell the story of what went on there. And one thing, Charles and Sella, that would be an interesting analysis would essentially, you could essentially run a regression of this data on month. So you would you basically do dummy variables for each month. And so then when you run the regression, you basically exclude one of the variables. So you'd like exclude January. So that way you would just basically be comparing everything to January. But you can exclude whatever month you'd want. But essentially see what months are the statistically highest, the statistically larger amount of waste. Because, I mean, my, Bayesian hypothesis would have been like October, November, but just, naively looking at the data, like, I mean, these jump out to me here, and this is like late winter, spring, so January, February, March. And then again over here, you see a spike, and then this is like spring again, where you've got but this is later spring, like April, May. So I'm just curious if there's any seasonality.
Do you think it's related to 420?
Well, you see sales spike, but I'm curious if that would just be so strange for like waste to spike.
Well, I mean, obviously they have to ramp up inventory, right? And it's not I mean, there's a lot of this is outdoors, but there's so much indoor production now that it's basically, 12 months a year. You probably have some sort, every month somebody has some harvest, assuming they've timed everything out.
So, like I said, when you run and that's why the regression's interesting here, is because when you run the regression, there may not even be a correlation for given months.
Yeah,
that's worth revisiting.
I couldn't really see much of a pattern. I think like September through December sort of were lower, but like the peak months changed from year to year. So I don't know why that is, and
it's worth revisiting. So seasonality, still something we're trying to wrap our heads around, but it's a fickle one. So you've got the top producers here. Once again, I think, and that was just what the person at Better Carbon Solutions suggested, and I think it was an interesting advice, because it wasn't something I would have thought of, but stressing on the story, I think the barrels is a little bit of you'd almost have to have like a legend that would say, assuming one barrel is 100 pounds or something like that. But that's how they do gasoline, right? So, but anyways, so it looks like there's really this pack of 1, 2, 3. There's really like this pack of 7 who were like out in the lead, and then it looks like these are. Well, it looks like this is almost a secondary pack here. Another pack of 6, and then these may just be like these firms look similar in size. So this is real interesting. But let's just look at some of the rest of your analysis here while we've got a bit of time. But this is my first time seeing it, so pardon me for sort of my hot takes. But we'll see what data you've wrangled up here.
This is so cool, Charles. This is the first analysis I've ever seen.
Oh, thanks.
And it is like, even to like, you know, a casual like me, this is like, I can still understand and glean like what you're getting at. So I think that speaks to your ability.
Thank you.
Interesting. So here you basically have the top 5.
So I don't understand this concept of growing waste. Like, what does that mean?
Oh, this is like, that's basically like, I mean, Sally, you may know better than I, but I think that's basically when they're just sweeping up like plant matter off of the floor.
Yeah, when you grow cannabis, one of the great enemies of cannabis like production is mold. And so there's like a lot of defoliation that happens in the growing process to ensure the highest like exposure of bud sites to light, because that's like, you know, where the money is. And sometimes, you know, they cull plants that just aren't making it, or there is definitely like growing waste produced in the life cycle of the plant as well.
Okay, thanks. Yeah, I mean, to me, this is a bunch of data. I don't always know what these terms mean, and it's hard for me to wrap my head around what is it, you know, what am I actually looking at, and what am I looking for? But
and I, like I said, like I wasn't super involved in growing or anything like that. So it's possible that the growing waste is coming from like a specific practice, industry practice, or some kind of thing that they're doing. But that's what I would assume that they're referring to anyway.
Okay.
It looks like the entry of it fell off. So it doesn't look like they're entering growing waste anymore, does it?
Right, although it's not listed as depreciated in the manual. So, but it looks like it's being depreciated.
That would, okay. Okay, so they may not be required to record it anymore. So we'll have to double check.
Then flower waste, there was like 3 entries. And so again, what is that? And obviously they're not tracking it, or those are mislabeled entries. And then the seedling waste
also falls off.
It also falls off. And then at one point, there's like 30,000 kilograms of seedlings. I mean, how much does a seedling weigh? 30,000 kilograms. I mean, that would be like, that would be a lot of seedlings.
Yeah, for sure.
So it looks like, okay, this would make sense. In July of 2019, they updated the traceability system. And so at that time, I think is when they deprecated certain fields. And it looks like they essentially just deprecated needing to record that waste. And my guess is some people just kept on recording it, even though they didn't have to, but then they kind of trailed off.
Okay, that's helpful. That explains a lot of what I'm seeing.
And similar thing here. So growing waste. So they're recording it up to 2000, up to July of 2019, and then that one trails off. So So really, what we just need to focus in here is this harvest waste.
Out of curiosity, do you know how strict they are about requiring producers to, oh, sorry, low-key cat emergency. Somebody tried to catch a bird through the window. That was dumb. Sorry. Do you know how strict they are about requiring producers to report these numbers, and like whether or not they audit them, or if there's like requirements by the state for that?
I don't, off the top of my head. I don't know. So that's an excellent question.
Yeah, I was just wondering. It's not that I expect you to know that necessarily, but I feel like, you know, people when homework is assigned and required and part of your grade, it's a little different. So I know for sure that, like, at least when I was working for Northwest Cannabis Solutions, they didn't always do it by the book, you know. And so I'm wondering if how reliable some of the numbers could be, or if they don't like penalize any of the growers, like or incentivize their reporting for certain numbers, like how that would affect the overall outcome of the numbers.
I think that's an excellent point. And I think that sort of drives home sort of a recurring theme of the meetup group is, so we haven't actually prepared any forecasts yet, but that's one thing that I always hedge my forecasts, because as you noted, it, you know, junk data in, junk data out. So it's sort of, it's true. You can, statistically show that if there is measurement error, then that does bias your results. It, depends on the amount of measurement error. So, a small amount of measurement error doesn't really lead to too much bias. But as you noted, I mean, if people are just eyeballing this, or if you have entire licensees who may not even be entering it, I mean, these numbers could be unreliable. So I think that's an excellent observation and should always be taken into consideration. So if you were doing analysis of this, or if you were presenting forecasts, I think you should definitely hedge this. You should say, okay, producers are principally care. They principally care about selling their cannabis, so they're probably going to record their, dry flower weight accurately. So I think if any good analysis should bring that up. Just to counter, I just always feel I heard somewhere that if you're not measuring it, you're not managing it. So sometimes any measure is better than no measure. So I think you should take it on face value. So these numbers could be wild. At least we have some numbers. So that's where you get your confidence intervals. So at least we have a measure of how much waste may be being produced, and we can kind of see where it would fluctuate. And so, like, if you were doing a monthly analysis, perhaps the entry error is the same month to month to month. And then you could just say, oh, well, we can still estimate the month effect, but we just don't know the magnitude, right? We're biased in the magnitude, but, our month effect, that wouldn't be biased. So, but that takes a little hand waving. So So I think there's two sides to the coin. It's basically, yeah, I think you need to acknowledge that there's noise in the data. It's incredibly imperfect data, and the producers don't even really have the incentive to enter it in accurately. But
Yes,
we need some measure of the waste. What were you going to say, Charles?
Oh, having spent a lot of time
Are you going to
with
chime
this
in, Charles?
data, there's no way that anybody could audit anybody. I mean, it is really, really messy. I need to publish that the amount of time it takes for like lab results, because I got to a point with it where I was like, I'm just making stuff up because I'm just, I'm having to I'm having to like fiddle with this data so much to make something out of it that it's just, it's just a made up story. Yeah, there's no way. This is really the data is really inconsistent. There doesn't seem to be anything that there doesn't seem to be any requirements of like like checking the data when it goes into the database. I think people enter whatever, and I think that they enter stuff like they don't enter it daily, or some people might enter it daily, some people might enter it weekly, some people might enter it monthly, which I think maybe explains some of those where the spikes in the amount of waste change like from April to May, because people, it's just depending on when they entered the data.
Totally. I feel like if anything, it's an argument to, encourage or advocate for that sort of like, I guess, incentivization of like reporting that information, just because like, I totally get that. I think it's really clear even to me based on like the really helpful charts and graphs that you've made that like, yeah, there is, as Keegan said, like a lot of noise in the data, and it would probably be beneficial on a lot of different levels to require and incentivize producers to report that more accurately. And like for sure, based on my personal experience, like I said, just working for that one producer, you can bet your bottom dollar that your mileage will vary. Like I really can't imagine that they were reporting a lot of this stuff accurately or consistently. Based on kind of like how they were running things when I was there and how they had been running things before I was there. So I think you're totally right. And I feel like, if anything, it's an argument to kind of like advocate for that stuff, to have better data in the future.
Yeah. So Oregon's supposed to be really strict, but I've never seen their actual raw data.
So those are excellent points across the board, and yeah, like you said, show us the data, because you're right. It would be like for Oregon, it'd be interesting because it does seem like they have a good handle on their data, but I'm curious, yeah, to the amount of noise, But it just takes good data wranglers, and so that's why, yeah, Charles, when you're doing your analysis, it's so good for you to explain like why things are so messy and the effects of it. Like you said, it's going to be tough to audit anything because it doesn't seem like there's much validation of the data. For example, like a valid harvest date, for example. So I think your analysis here has been fruitful, and I think there's a lot of lessons learned here with data analysis. You spend 90+% of your time just working with the data, and you really need to be upfront with your audience about what steps you took, like Charles was saying, like with the lab result data, like you can't just you can't just squeeze things into a box and like, just, wave your hands about the things that don't make sense. You have to be upfront with your audience about, okay, we've got maybe not the best data entry here, or not the best incentives to enter the right data. The data entry may be delayed. But I think I'm just reiterating what you two have already said here. But anyways, I think you two actually captured the heat of things, the meat of things. So I think I'll go ahead and wrap it up there for the day, and just let people get on and start exploring the data on their own. But for next week, we can work on some forecasting, and I'm going to have a look at wrangling this data myself, because I want to sort of replicate Charles's analysis, because you've done an excellent job here.
Thanks.
Yeah, thanks for sharing, Charles. This is super duper cool. I learned a lot today, y'all. Thanks so much for walking me through what y'all do on the regular.
Oh yeah. Thanks for joining, Sella. Sometimes we get a bit more hands-on, but like this data set is giant, so we're a little limited in scope. But it's awesome that Charles put together these charts, because rule number one, look at the data. So that's what we did today. So.
And they are beautiful charts. But anyways, in the future, if things are more hands-on, I definitely don't mind observing you and Charles kind of in your like natural, I guess, environment, working on stuff and collaborating, because I would also find that helpful. So please don't feel like you have to teach to the back of the class, so to speak. I'm just really excited to kind of have exposure, just because in my personal like tech journey, a lot of it is just like studying JavaScript or studying whatever it is I'm studying. I'm still trying to learn a passion for something. So I think this is definitely a step in that right direction, especially in terms of like exposure for specialization in the future. So I really appreciate it.
Well, and it's entirely open. So if we want to look at charts and talk about Charles's analysis, then by all means. Are you going to chime in, Charles? Or?
Yeah, and really, your insights from working, in the industry, that was really helpful. I mean, there's, because when I look at this data, I don't, again, I don't have anybody to go to and ask, like, why is this, or, but you gave me some good insight, and now I can have a better understanding of what's going on.
Well, I'm glad I could help in my own way. So, let me know if there's anything else I can do on the sort of like off time in terms of like getting a little more familiar. I'm definitely like kind of rubbing my hands together and looking at Python as like my next language I'd like to learn. But given how JavaScript is going, that may be in some time yet. So we'll just have to see.
I think Python is easier.
I don't know, but it looks super. I honestly love optimizing stuff, and I love automating tasks as much as possible. And so Python is looking pretty delectable these days. So it's really cool to see the kind of heavy lifting that y'all are accomplishing with it. So I definitely am starting to like feel those kinds of like connections happening. And that's super exciting, just because I'm not gonna lie, just learning JavaScript in a vacuum is kind of a slog. So getting to see actual practical applications for various languages was like super exciting and very energizing. So I really, really appreciate it.
Sure.
There's room in the world for both. So they, you've got a hammer, you've got a screwdriver. So it's, they each have their own, they have their own purposes.
Definitely.
Yeah.
But very, very cool, y'all. Thank you so much again for your time.
Awesome.
Great job, Charles. This thing was so cool.
Yeah, thank you.
All right, y'all. Catch you next week.
Yeah. All right, have an awesome day.
Okay.
Until next week.
Thanks, you too.
Okay. All right, bye.
Bye now.